We are going to discuss about the linear and the non-linear operations on images. So an image is considered linear, operation is considered linear if it satisfies, that is, there is some kind of a scaling and an offset. So these kind of operations are said to be linear operations. These linear operations, they help to preserve proportional relationship between pixel intensities. Um, so these might involve simple and so these are simple and computationally efficient, and they help to preserve uh, intensity differences. Consider one example: additive offset. Now additive offset means, here I perform some value, so that that particular pixel becomes brighter. So if the original pixel is 100, then I will add 50 to it, and so it becomes brighter. In case if I try to reduce, if I say minus 50, if this is minus 50, which is less than 0, then the image will become darker. First one is additive offset. The next one is multiplicative offset. So if the p value is, if I multiply with anything more than 1, then it will increase the contrast. Otherwise it will, if the value is lying from 0 to 1, then it will decrease the contrast. Like for example, if my p value here is p into the pixel value, so here if my p value is 2, so 2 into 100, 200. Like this, all the pixels will be multiplied by 2. Then there is image negative. Now in image negative, I perform L minus 1 minus f of x comma y. So here 255 minus, if 50 is the value, then I will get 205. So dark areas will become bright, bright areas will become dark. That is image negative. The next one is contrast stretching or the histogram stretching, which we have already seen in detail. In the non-linear operations, now the non-linear operations is, that is where I apply some kind of a non-linear function to the pixel. The change that is applied to one intensity level is not proportional to changes that are applied to others. So it leads to powerful contrast enhancement, and it can help to emphasize specific intensity ranges, leads to better visual quality. So the first one is logarithmic transformation. Like for example, C of log of 1 plus f of x comma y. So log of the value is used, and here it can help for astronomical, Fourier spectrum visualization, medical imaging. These might be used. Then there is power law gamma transformation. That is, uh, so I raise the pixel value to the power gamma. So here, if the gamma is less than 1, it will brighten up the image. If the gamma value is more than 1, it will darken up the image. Square and square root, performing the square for the pixel or square root. If I perform the square, then it will brighten up. If I perform square root, it will darken up. Histogram equalization. So this is one non-linear operation which we have seen in the other video. Then there is histogram matching. It transforms an image so that histogram matches a desired histogram. We will see one example for this. So here I am adding 50, 1.2, multiplying each pixel value by 1.2, 255 minus the image, histogram stretching. Under nonlinear operations, log transformation is performed, then gamma correction is done, square root, and histogram equalization. And so with the original image, I'm getting these results. So brightness plus 50 brightness into 1.5, contrast into 1.5, negative of the image. As you can see, the white pixels are changed to black and black to white. Then histogram stretching, log transform, gamma with 0.5, square root transformation, and this is histogram equalization.